Trig Lesson 4 ratios. Suppose theta is an angle in standard position with the terminal arm in quadrant 3. So if we did a quick sketch, standard position, so this is my initial arm, quadrant 3 is this one down here, and so we're looking at theta being some angle that looks like this. We're told that cosine of theta is negative 3 over 4. We know that cosine of theta in terms of x, y, and r is x over r. So we know that x is equal to negative 3 and r is equal to positive 4. What are the exact values of sine theta and tan theta? So we need to find y. We know that x squared plus y squared equals r squared. So we know that negative 3 squared plus y squared will equal 4 squared. So 9 plus y squared equals 16, or y squared equals 7. So y is equal to plus or minus root 7. We need to look at whether y is positive or negative in the third quadrant. Our y value is going down. Therefore, y is going to be negative in that quadrant. So y will be equal to negative root 7. Now we can find our other two trig ratios. So the sine of our angle is equal to y over r, so negative root 7 over 4. And tangent of theta is y over x, so negative root 7 over our x value, which is negative 3. Because we have the two negative signs, we end up with just root 7 over 3. A quadrantal angle is an angle in standard position whose terminal arm lies on one of the axes. These angles are 0 degrees, so if we stopped here, then 90 degrees if we came this far, 180 degrees, 270 degrees, or 360 degrees. Look at the values for an easy to see measure like 1 and negative 1. So if we picked points on each of those terminal arms. So let's start with an angle that's 0 degrees. Means that our x value we could pick to be 1. Our y value is going to be 0. So x would be equal to 1. Our y value for that point would be 0. And r, which is the distance from the center out to that point, would also be 1. And so we can find really easy measures there. Let's use this to help us find some exact values. So let's find the ratios of 0. So again, that means that there's a point on this terminal arm that would have the point 1 and 0. This would be my x value, this is my y value, and r would also be 1 because it's the distance from the center out to that point. So sine of theta is equal to y over r. So our y value is 0, our r value is 1. 0 divided by 1 is just 0. The cosine of our angle is x over r. Our x value is 1. Our r value is 1. That looks like a negative sign, that's not supposed to. And so our cosine of 0 would be 1. Tangent of theta is y over x. Our y value is 0. Our x value is 1. 0 over 1 is 0. So you can go through and complete that idea for all of those angles. I'm going to do one more. If we do 90 degrees, means that we're picking a point up here. In this case, our x value would be 0. Our y value would be positive 1. And our r value, the distance from the center to here, would also be 1. So if sine is y over r, our y value is 1, our r value is 1, and so the sine of 90 degrees is 1. Cosine of 90 is x over r, so it will be 0. And the tangent of 90 is y over x. So y over x is 1 over 0. We can't have 0 in the bottom, and so this value is undefined. We could fill in the values for 180 and 270 in the same way. We would find that the sine of 180 is 0, the cosine is -1, the tangent is 0, sine of 270 is -1, cosine is 0, and the tangent of 270 is undefined. We're going to use something a lot that's called the cast rule. The cast rule tells us what quadrants trig ratios are positive and which quadrants trig ratios are negative. So if we look at this first quadrant, our x and our y values here will both be positive. R is always positive, and so in this case, all three of our trig ratios will be positive. Let's just write those trig ratios up again. Sine is y over r, cos is x over r, and tangent is y over x. So let's look in quadrant 2. In quadrant 2, x is negative and y is positive. So anything that's negative is things that have an x value in it. So cos and tan would be negative. That means the only thing that's positive here is sine. In quadrant 3, both x and y are negative. So sine would be negative, cosine would be negative, but tangent, which is y over x, would be positive. Looking in quadrant 4, x will be positive, but y will be a negative value. So in this case, sine will be negative, cos will be positive, but tangent will be negative. And so the letters that I've written in represent the trig functions that will be positive in those quadrants. We call it the cast rule because we start down in quadrant 4. C, A for all, S for sine, T for tangent. Solve for an angle given its exact sine, cosine, or tangent value. When we see the word exact, you should think about those special triangles. So we had two special triangles. One which started from that 30, 60, 90 triangle. So this was 30, this was 60. The short side was 1. The longer side from our original equilateral triangle was 2, and we found this side to be root 3. We also had that 45, 45, 90 triangle, where the two sides were the same, so they were both 1, and the opposite side was, root 2. So part A says the cosine of theta is negative root 3 over 2. So we want to think about what trig function, what angle has root 3 over 2 as a cosine. Well, there's no root 3's in this triangle, so that means that probably I'm dealing with this one. Root 3 over 2 would come from these two. And so if we look at the cosine of 60, cosine of 60 is adjacent over hypotenuse, so that would be 1/2, so that doesn't work. What about the cosine of 30? The cosine of 30 is adjacent, which is root 3, over hypotenuse, which is 2. So that means that my reference angle here is going to be 30 degrees. I now need to look at where we could end up with that negative sign. So what quadrants do I have to be in order for cosine to end up negative? Our cast rule that we just wrote said that cosine is positive here and positive here. So the only two quadrants where cosine could be negative is in quadrant 2 and in quadrant 3. So in quadrant 2 means that this would be our 30-degree reference angle. This is the angle that we're looking for. So we would do 180 minus 30, or 150 degrees. So that's one possibility. The second possibility is if our terminal arm lies in quadrant 3, maybe I'll redraw that picture. If it's in quadrant 3, our 30-degree reference angle is in here, and we're looking for this angle. So it will be 180 plus 30, or 210 degrees. This is our last example. It says determine the measure of theta to the nearest tenth of a degree. So tenth of a degree means we're looking for an approximate value, means that you're going to use your calculator finally for this one. Given that the cosine of theta is negative 0.6753. So you're going to use your calculator to calculate the cosine of theta. And if we put in the cosine of theta as decimal 6753, we end up with a reference angle of 47.5 degrees. If we look at our cast rule, the only quadrants where cosine is negative is again quadrant 2 and quadrant 3. And so if we're in quadrant 2, remember our reference angle is formed with that x-axis, so we would have 180 minus 47.5, so 132.5 degrees is one possibility. If we're in quadrant 3, we would do 180 plus the 47.5, and we end up with 227.5 degrees. So those are the two possibilities that we can look at.